The addition of bromine or chlorine to alkynes. So if we start a reaction with an alkyne, alkynes, like alkenes, undergo electrophilic addition reactions. And one that we saw with alkenes was the addition of bromine or chlorine in an inert solvent. So if we add bromine or chlorine, this would be the electrophile in the reaction. And the solvent that we will see for this reaction will be something like dichloromethane or carbon tetrachloride. And so these solvents are ones that we noted in the previous chapter are inert solvents, which means that they will not compete as a nucleophile in the second step of the reaction. So they are not competing nucleophiles. So the mechanism for this addition with an alkyne is not completely understood, but we do know what the products tend to be. If you add one equivalent, what we tend to see is that that one equivalent adds in an anti-addition fashion. So we tend to get the E-alkene, where the bromines or chlorines have added to the opposite face. So it is an anti-addition. Halo-substituted alkenes, actually a dihalo-substituted alkenes, are less reactive than alkynes and less reactive than alkenes, which means that we can control this reaction with stereochemistry. So if we have one equivalent of bromine, we will get this product. If we add a second equivalent of bromine, it will also add across the alkene, and you will end up with a product that has overall had 4 bromine atoms added to it. So let's look at a couple more examples. So let me draw another alkyne. Okay, so if we start with this alkyne and we add one equivalent of chlorine in dichloromethane. So what we expect will happen here is that we will add one equivalent of chlorine and it will add in an anti-addition fashion. So our alkene will end up being a trans-alkene. So we will have one chlorine atom pointing up and one chlorine atom pointing down. If we use in another example, so we draw a different alkyne, if we used 2 equivalents of our halogen, and let's use bromine for this example, and we will use carbon tetrachloride as the solvent, what we will see is that 2 equivalents of bromine add across that alkyne, like we saw up here. So I'm going to number this carbon chain just so we can see a little bit clearer where the bromines are adding. This will be a fast trick for us to draw the product, because if the bromines are adding across the alkyne, we should see 2 bromine atoms on carbon 3 in the product and 2 bromine atoms on carbon 4. So I'm going to draw a 7 carbon chain. And in the product, I will have 2 bromine atoms that have added to carbon 3. And 2 bromine atoms that have added to carbon 4.